Welcome back, B-Weekers. For everyone involved, see everybody, there we go. For everyone involved, we should have completed the formative from It's Learning. Yeah. Should have completed the formative. And then you also should have watched a video over the weekend. If you didn't watch the video, you might be a little lost today. Okay. Two things. One, you need out your formulas sheet, the pink identity sheet, and you would also probably want to have out your unit circle, okay, so that we can have that ready to go. And that goes for everyone. The formative, or not the formative, the identities sheet and the unit circle is what we would like to have out today. Okay? All right, so what are we doing when we solve an equation? When we solve an equation, we're finding values of x or values of whatever our variable is that make that equation true. Okay? So we're finding values of our variable to make a true statement. When it's a trig equation, we're not finding values of our variable, we're finding angles. Finding angles to make our truthiness. Okay? So, we want to solve for x on the interval 0 included, 2 pi excluded, which is, if you think about the unit circle, that is the first lap of our unit circle. So we include 0, but we don't include 2 pi because we've already got 0. Okay? So that's why it's always solved over that interval. And we basically, what we want to do when we're doing these, and what you probably learned on the video that you watched over the weekend, is we want to get it in factored form and then get trig function equals some value. Okay? And then we can solve from there. So, if I were doing this fine piece of algebraic trigonometric combination, I would first factor out a tangent, because I looked at it and I saw I got a tangent in the first term, I got a tangent in the second term. I'm going to factor out a tangent. If I factor out that tangent, then I'm left with tangent of x times the quantity, the square root of 2 cosine of x minus 1 equals 0. Once I've factored and can't factor anymore, which I can't factor this equation anymore, once I've factored and can't factor anymore, then algebraically we would set each of our factors equal to 0. So we can do that here. We can say the tangent of x is equal to 0, and the square root of 2 cosine of x minus 1 is equal to 0. Tangent of x equals 0. I've solved for the trig function. cosine of x here, or this one, I'm probably going to have to add 1 to both sides. That would give me the square root of 2 cosine of x equals 1. Then I would divide by the square root of 2. And that would give me cosine of x equals 1 over the square root of 2, which if I rationalize that denominator, that would be the square root of 2 over 2. Multiply both top and bottom by the square root of 2. Okay? Now, we go to our unit circle, and we say to ourselves, self, where on the unit circle, first lap, is tangent equal to 0? Well, remembering back to the fact that tangent is sine over cosine, or y over x. So I need y to be 0. Well, that happens at 0 radians and pi radians. At 0 and at pi, tangent is equal to 0. Then I look at my other one. Where on the first lap of the unit circle is cosine equal to the square root 2 over 2? That happens at pi over 4, and again at 7 pi over 4. And so all of those combined are my answer. We're going to get multiple answers out of these problems. Okay? Questions on that? It's basically the same as what you learned in the video this weekend. It just is taking it up a notch because we're adding in some fun type of algebraic type equations. Okay? So, same thing here. Now, algebraically, way back, if we were to solve, if we would have said xy squared equals x, way back in algebra, you probably learned, well, I got to get everything onto one side. And that's great, because that's what you need to do. The downfall with a problem like this is that you want to divide both sides by x right off the start. And the problem with that, just writing y squared equals 1, is that you lose a factor. Okay? We can't divide by a factor. We have to factor our factor. Okay? So this right here, this is bad. If we were simplifying, it'd be good math. But we're solving, so it's bad math. Okay? We have to factor our factor. So in order to do that, we first have to get everything onto one side and get it equal to 0. Your goal for all of these problems, when you have multiple trig functions, is to get it equal to 0. If you have one single solitary trig function, then you can get it equal to a number. But if you have two 3. Got to get it equal to 0. Okay. Then we can factor out a sign. Could factor, but don't need to factor the tangent squared minus 1, perfect square minus perfect square. If you wanted to factor it, you could, but I'll show you a way around it. So then we would say sine of x equals 0, or tangent squared of x minus 1 is equal to 0. Adding 1 to both sides would give me tangent squared of x is equal to 1. Square rooting both sides is going to give me tangent of x equals, and here's the kicker, plus or minus 1. Because I'm square rooting and I'm solving, I need that plus or minus. Okay. Had I factored it one more step up here, I could have gone sine of x times tangent of x minus 1 times tangent of x plus 1 if I really wanted to. And then that's where we get the plus or minus 1 from. Okay. So, sine of x equals 0. Sine is my y. Oops, let's do this. Let's bring back our old pal, Mr. Unit Circle or Mrs. Unit Circle, whichever one you prefer. There it is. Sine is 0, whereas my y value 0 happens again at 0 and pi. Tangent equal to positive 1 is at pi over 4. And 5 pi over 4. Tangent equal to negative 1 is at 3 pi over 4 and 7 pi over 4. So this particular trigonometric equation produced for us 6 answers. Okay? Love it. Good time. What I'd like you to do now is I'd like you to try one on your own. Try this one for me, number 24. I don't even know why it's called number 24, probably because way back in some old worksheet it was number 24 that we stole it from. Okay? Try solving this one on your own. So first I would add 3. That would give me 4 cosine squared of x is equal to 3. Then I would divide both sides by 4. That would give me cosine squared of x equals 3/4. Then I would square root both sides. When I square root, that automatically brings in the plus or minus. So then that would be cosine of x equals plus or minus the square root of 3 over the square root of 4, and the square root of 4 is 2. So I'm looking for where cosine of x is equal to plus or minus the square root of 3 over 2. So it is positive at, well, bigger here. Actually see it. It would be positivo at pi over 6 and 11 pi over 6 it would be a negativo at 5 pi over 6 and 7 pi over 6. Yay? Nay? Yays? Majority of yays. At home, thumbs up if it's a yay, thumbs down if it's a nay. To the side if love all the thumbs up. Love all the thumbs up. Alright, let's try another one. Hey, let's do it. Go for it. Since we have two trig functions, they happen to be the same style, or same one, but one's squared and one's not. Since we have two, we got to get everything onto one side. Then we can factor out a secant. Then say, where is secant of x equal to 0? And where is secant of x minus 2 equal to 0? Secant is 1 over cosine, correct? So where is 1 over cosine equal to 0? Anyone? Lexi? So never, right? So that one doesn't really matter to us. Okay? This one doesn't matter to us because it can never happen. Okay? So that one doesn't matter. That one's always going to have a value. Okay? Adding 2 here. That's going to give me secant of x equaling 2. If I reciprocate both sides, legal because I'm doing it to both sides. If I reciprocate both sides, secant is 1 over cosine. It would become cosine. Reciprocal of 2 is 1/2. So where is cosine equal to 1/2? Pi over 3 and 5 pi. Okay. Ooh, I like it. I like it a lot. I'm going to let you guys try this one. See what you guys do with this one. I'm going to let you try it, see what you can do, and then I'll come back. Let's algebraically talk about this one. What is the big issue in this problem that you see? Can't factor it. Why can't you factor it? More importantly, there's two different trig functions, right? In terms of variables, there's two different trig functions going on. Okay? So we can't factor it. Is there a way that we could get it to one trig function? Is there a way that we could get it to one trig function? What I would do is I would take this sine squared, and using the hammer, I would make that into 1 minus cosine squared. Okay. Gotcha.
Oh, I'm Sawyer.
Yeah. You can write, sure.
Pretty sure.
Let's check it out. Yep. So everybody else, go from here now. Because now we're at one trig function. So now we've got one trig function. Now we should be able to go with it. I just went around the room and I spot checked everybody. And so we've got, everybody got to here. Distributing in the 2. Love it. Okay. What would we do next? Combine them. Yep. Okay. Okay. But what's wrong with it, Kylie? We like our positives, right? So we're going to change all of our signs. So this becomes positive, this would become negative, and this one would become positive. Okay? Now, it's no different than if I said factor that purple one. Right? How would you factor the purple one? How would we factor that purple one? Who's that? Brent? Sure. So let's do that over here. Our parentheses are just going to have to be a little bit bigger to do that. So then this is going to become 2 cosine of x and cosine of x. Just like over here, this would become 2y and y. What are my only choices for the 1? What times what gets me 1? 1, right? This is going to be 1, 1, 1. What are the SIG ends in both sets of parentheses? Both negative? And does it work out? So in here, we got a minus cosine of x. Out here, we got a minus 2 cosine of x. Together, those give me minus 3 cosines of x. Boom. Nailed it. Okay. Now we've got it factored. Now we can set our factors equal to 0. and we can solve those. Cosine is equal to 1/2 pi over 3 and 5 pi over 3. Cosine is equal to 1 at 0. Not at 2 pi, because remember we're not including 2 pi in that first left. We're including 0, but we're not including 2 pi. Yeah? Love it. Love that problem. You try that one. Whoa, that's great. The sine of x that I want to say is minus 4 and 2 sine of x, and I want to say it's plus 1. Because then we get negative 8 sines of x on the middle two, positive 3 sines of x on the outer ones. That gives me negative 5 sines of x. 4. So then we could say that 3 sine of x minus 4 is equal to 0. So 3 sine of x is equal to 4. So sine of x is equal to 4 thirds. 2 sine of x plus 1 equals 0. 2 sine of x is equal to negative 1. Sine of x is equal to negative 1/2. Yep. Can sine ever be 4 thirds? Nope, because sine has to be less than 1. 4 thirds is bigger than 1. That one gets thrown out, extraneous solution. Sine equaling negative 1/2. So that would be 7 pi over 6 and 11 pi over 6. Yes? Love it. Love it. Yeah? One more. Let's do one more, and then I think you can work on your worksheets for the remaining time. Okay? Because we're pushing that hour-long time frame, so let's see what we got here. Right off the start, what's the problem? What's the problem right off the start? Right from the jump. Can't factor it because it's two different trig functions and it's subtraction between them. Right? Okay? So we gotta manipulate. Which one do you want to manipulate? Secant or cosine? Secant. What is secant? It's 1 over cosine. Okay? So this first term is really 3 over cosine minus cosine doing 2. fractions, let's get rid of it. We're okay with that. Okay? So we're going to take this entire equation, and if I want to get rid of that fraction with a cosine, I'm going to multiply by cosine of x. There, and there. I got to multiply the entire equation by cosine. If I do that, 3 divided by cosine times cosine is just 3. Cosine times cosine is cosine squared. 2 times cosine is 2 cosine. Zero going to equal cosine squared plus 2 cosine minus 2. If I move everything to the right side. Two numbers that multiply together to be negative 3 and add together to be positive 2. Two numbers that multiply together to be negative 3 and add to be positive 2. Negative 1 and negative 3 multiply together to be positive 3. Positive 3 and negative 1, like positive 3 and negative 1. And shabam, we be factored. Okay. So then we can say the cosine of x plus 3 is equal to 0, and the cosine of x minus 1 is equal to 0. And we can say the cosine of x is equal to negative 3, and the cosine of x is equal to positive 1. Can cosine of x ever be negative 3? No. Be in between negative 1 and positive 1. Where is cosine of x equal to positive 1? At 0. The answer here is just 0. Okay? In your pink packet from the last couple of weeks, there is the 5.1 Solving Trig Equations worksheet. I believe that it is the third worksheet, the third sheet in the packet, if I'm not mistaken, that you can be working on from here. Okay? That's all I got for you today. At Homer's, make sure that you have your formative assessment done, because it was due by last night. If you don't, this would be a great time to get that done and get that submitted. Okay? Have yourselves a great, grand, and wonderful